So, good morning, good afternoon, good evening from wherever you're watching us at. My name is Mr. Mwangi from St. Francis, and today we will learn about fractional distillation. And in this process, the process is carried out to separate the various components of air. We have very many components of air, which include nitrogen gas. We also have oxygen. We also have carbon dioxide. We also have noble gases, which are also known as rare gases or even inert gases. Then we also have dust particles, and then we have moisture. Those are various components of air that can be found present in the air. Now, this fractional distillation process is aimed at separating each one of them so that at the end we may obtain the rare gases, that is mostly argon. We can also obtain oxygen and also obtain nitrogen from this process. So this process starts at this point where we take all the components of air, the air with all the components present, then we pass it through the filter. At the filter, dust particles are filtered out. So we remove the dust particles at the filter, at the purifier. Then from there, the air that is remaining with all other components is passed through this pipe to a chamber which contains concentrated sodium hydroxide or concentrated potassium hydroxide. This air passing through here is dust free, meaning it does not have dust particles. When it is taken here, carbon dioxide is removed. Carbon dioxide is separated from all other components because carbon dioxide easily dissolves in concentrated sodium hydroxide and also concentrated potassium hydroxide. From there, the air that is free from carbon dioxide, that is CO2 free air, is taken to the next chamber, which is the cooler. The cooler is maintained at negative 25 degrees Celsius, meaning this is very low temperature enough to convert water from, remember here it is in form of moisture. It is little enough, a very small temperature, to convert water from moisture to liquid, then to solid. So at this point, water is converted into liquid at 0 degrees. Then at negative 25 degrees, it has already reached its freezing point. So it changes into solid in form of ice. At this point, the water moisture is removed. Then the air that does not contain moisture, does not contain dust, and does not also contain carbon dioxide is passed through this part and taken to the compressor. Here at the compressor, the air, the remaining components of air are compressed at a very high pressure, that is 200 atmospheres, and very low temperature again, that is negative 200 degrees. So at this point, the air is compressed with high pressure and low temperature, in that the air now changes from gaseous state into liquid state, because these components of air that have remained have reached their boiling point. Therefore, they will change from gaseous state to liquid state. So at negative 200, they are compressed, and then the liquid air is taken to the fractional distillation chamber. Here at fractional distillation chamber, remember the gases are coming out from the compressor at negative 200 degrees. So the gases are very cold at negative 200. So at the fractional distillation chamber, temperature is added slowly by slowly. So here, remember we are at negative 200 degrees. So when we add temperatures slowly by slowly, we add, first of all, we add 4 degrees from negative 200 degrees. So we add 4 degrees. So we'll end up with negative 196 degrees Celsius. So at negative 196 degrees Celsius, nitrogen reaches its boiling point. Therefore, it changes from liquid now to gas. Having changed from liquid to gas, the others remain in form of liquid. Therefore, nitrogen can easily be tapped out in gaseous state. Then from there, at negative 196, we add 10 degrees. We add 10 degrees Celsius. So we get negative 186 degrees. We are adding these temperatures slowly by slowly. So at negative 186 degrees, we now get to the boiling point of argon. Argon boils at negative 186 degrees. Therefore, at this temperature, it will change now from liquid to gas. Therefore, it will be easily tapped out. We are left with, we have already tapped out of the nitrogen, and we have tapped out the rare gases. That is, the rare gas here is argon. We will be left with oxygen. At this temperature, at negative 186 degrees, we add another 3 degrees Celsius. So, adding the degrees Celsius, we will get to negative 183 degrees. So, at this temperature, negative 183 degrees, oxygen now reaches its boiling point. Therefore, it changes from liquid, remember at this point it was in liquid form, it will change from liquid to gas. Therefore, oxygen can also be taken out. It can easily be tapped out. So, therefore, these gases are separated so that they can be taken to their various stations where they are needed. For example, nitrogen can be taken to be used for storage of semen in form of refrigerant. It can also be used to manufacture nitrogenous fertilizers. Then it can also, nitrogen can also be used in the manufacture of ammonia in the Haber process. Then argon is used in bulbs. It can also be used in other processes. Oxygen is used by deep sea divers. It can be used by patients in hospitals. It can be used by mountain climbers. Then it can be used in very other many stations, in very many other places. So that is the fractional distillation process, where we separate the components of air. Then we end up with oxygen, argon, and nitrogen. So we can end up at that point. Have a good time on the day. Bye bye.